Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 434 frequencies of shortest super sequences. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I think this one is a little bit awkward, the problem statement for sure. Why I say that is because, well, the real problem is in the constraints, right? Which is that each word only has 2 letters. So that's a really big one. They should put it on top. That's part of the problem. Why not? Put it here. Why? You spend so much time defining shortest common super sequence. You missed the part where that is like majorly the problem. Like I know it's a constraint, but a constraint is part of the problem. All right. I went aside. Sorry, I'm obviously venting at the problem statement or problem writer. But in any case, the problem itself is fine. But they should mention this, and 16 as well. So okay, so I think the first thing to think about this one is that there are only 16 things, right? So that kind of limits, or that opens up possibilities as to how expensive we want to be, right? Like we can be expensive as we want. So the key idea here, the key observation, and it took me a while to figure out, is that if you have 2 of one letter, it is enough to do anything, right? And why did I say that, right? So if you have like AA, right? Or actually, let me step back a second, right? So it turns out that, let's say without loss of generality, I'm going to use, I don't know, yeah, like the first 5 letters or whatever, right? So yeah, let's say we have A, B, C, D, E, D, C, B, A, right? So for 5 letters, this is it. This will always be the answer, or always be the worst answer, right? I mean, you can construct other ones similarly, but that's the idea, is that because now for every A could be the beginning of all 4 letters, and it can also be, let me change the colors. A can also be behind every letter, right? And you can say the same for all the other ones, right? B is before all 3 plus the A and the B even, right? And the same thing, this B is behind all the other ones, and the A and the B if you need it, and so forth. So anyway, I mean, you can work that out, but that is going to be the worst case scenario. Not to say that that's the answer in the minimal sense, but that is just one way to do it, right? And I was thinking about it, well, in that case, that means that in the worst case, also, each letter can only have two instances, right? So that's one. That's the first observation. The second observation, if you want to kind of think about how it works, is that for any letter, you can actually just put it in the beginning and the end, right? Let's say we put the B in the beginning, B at the end, then everything inside is going to be also before and after, right? So 2 will always be enough, right? Okay. So then the only question is, for a given letter, is 1 enough? Question mark. So that's the tricky part about this one. But one thing to see about this then, right, is that there are only 16 distinct characters. And because there are 16 distinct characters, that means that there are only 2 to the 16 distinct things we can test, right? I end up not doing it necessarily quite this way. And we'll go over my solution, which honestly, it's fast enough, it's good enough, but it's not as clean as I would like after I kind of assembled, if you will, out of pure solution. And I was actually similar to that idea, but this is the crux about most of this idea, right? Okay, so let's go over this idea, my implementation, and then I'm going to go over another way of thinking about it. Feel free to fast forward, but I'll also do a live solve on this part. So yeah, okay. So yeah, so this part is just a lot of crux. It's just a lot of like setting up, right? So for each word, we first of all we map it to for each character we map it to a number from 0 to 15. Just to I don't know. I mean, this is just what this thing does. It's just to make it easier to handle. And this one we do use bitmask. I'm not going to go with bitmask in this video because I feel like it is already going to be a long video. So yeah, my apologies, but this is a bitmask dynamic programming. I have videos on bitmask dynamic programming in the past. Check those out for a given problem, right? If it's the same, then we have to force it, right? Because for example, if we have, say, if AA is an input, well, you need two A's for it, and if you need two A's to it, you can just put one at the beginning, one at the end, and that's fine. It just kind of makes it so that it's forced, right? Is what I have. Otherwise, otherwise we have this before thing. It just lets me know what is before this character, right? So before sub x is equal to y means y has to be before x. I mean, it doesn't have to be, but there has to be at least one instance of, right? So that's basically how I parse this. And then I just wrote, dynamic programming, right? And the idea here is that, okay, I call this dynamic programming, and this is bitwise for operation, right? So free is a bit mask telling us what characters are available, or what numbers from 0 to 15 are available. And then now I wrote a DP that contains, okay, it's basic, so it returns two things, right? Returns two things: the shortest length, and also the bit mask that another bit mask. This bit mask is different of the answers, and this one is different in that so the free bit mask, or bit mask free, is just a Boolean element, or each bit is a Boolean. Each bit is a Boolean or bool, I suppose. Whether we can use this number, and then this bit mask, answer bit mask, is just so it actually contains a set of bit masks where each bit is a bool on whether you need a 2 for that answer, right? Oh, sorry, need a 1, or you can have a 1. You have a 1 actually. 2 otherwise, right? For the numbers that we haven't used. And a lot of things is implicit, right? Because for example, if you haven't gotten certain characters, then it's not going to show up here. So I think that's what kind of saves it a little bit, right? Okay. So for example, if my go-to, my second set returns, just to kind of give you an example real quick. So if the answer set contains numbers, say 0, 5, 2, then what that means is that, let me sort it. In bitmask, this is just 0, 2 is this, right? And 5 is 101, right? So that means that they're all ones in the solution. You have one for 0, 2 for 1, 3. Sorry, 1 for 3, right? Basically 1 bit at a time, and telling you the solution. And that's how I encoded it, right? So 2 for 0. The 0th index character, 1 for this 1, and then 2 for 3, right? So that's all that is. You can think about it as actually 1 plus whatever the bit is, giving you the answer. Of course, this is actually not a possible return result. Why? Because by definition, these are not all optimal, right? Or ideal, because these are zeros. That means that the cost of this is going to be 3, because they're 3 ones. The cost of this is 4, and the cost of this is 5, right? So not all of them are possible, just to be clear. And as a result, that actually limits the possible answer a lot, because now you just limit a lot of different things, right? And that's basically the core part of it. The rest is bitwise, bitmask dynamic programming, sorry, which is that we try every number from 0 to n minus 1. If it's not free, we skip. If it is free, then we check that. This is a little bit tricky, right? So if it's free, that means that this part is actually hard to it's not hard to explain, but it's just hard to visualize a little bit if you haven't done a lot of bitmask before. Remember, we call it that before sub I means all the characters that are before I, right? So if the character, so that means that because this loop is almost like a take no take, right? Take no take. What if we only use one? I don't know why one is one of this character, right? So if we use one of these characters, that means that everything we've seen it before, well, we don't care about, it's fine. But if there's a character that has to be afterwards, but oh, sorry. Yeah, it's the other way, sorry. If a character has to be before this character, but it's still free, that means that we haven't processed yet. So that means that you cannot have one because it has to be before the, because that means that the the characters that are free means that we're going to add them in later, right? And so if it's before the character we're using now as a requirement, so these are requirements, then that means that we can't do it. So that's basically the short part of this. And this bit mask is necessary, right? Because this reduces the complexity by O of n. Because it just makes it a lot faster, but it actually does not, let me rephrase that, or correct myself. It does not reduce the complexity by O of n, because technically each bitwise operation still takes n, if you want to go that way. But it is much faster because instead of n numbers, we have one number of n bits, so that's why it is faster. And that's what I have for this one, right? And then the other part is that if I is not an F, right? And of course, F is what we have for the double letters, right? Because if it's a double letter, then you have to have two, so you cannot even try to have one of them. And that's really the idea. And then now we just, and like I said, this is take no take, except for instead of just returning R, we also return G, right? G is, what is G? G is the answers bit mask. I think I use G for groups, but the bit mask of all these things that allows us to kind of put in the answer, and that's it. G contains all possible answer from this point on in our state, and yeah, so for X, and if this is, and this is just min logic, right? If it's less than, then we set it to min, but we also means that for each item in G, we want to add it so that we consider I, the index I, the character represented by the index I, we can have only one character. So that's why we add this plus the a bitwise OR of the thing, right? So it just adds that to the Boolean. And the same thing for if it's equal to, then we just, for each possibility, we add this thing to the possibility, right? And that's it. And otherwise, you have to force a 2, right? It's forced a 2, so we just take we do the recursion, we force the 2, and then if it's equal to, and this is the same thing, right? Except for that, because this is a 2, we do not do a bitwise OR, we just kind of keep the same number. And that makes it a little bit simpler, right? Yeah. And that's it. And then, I have this here because I was just like auditing something. But yeah. So the tricky thing is that the complexity, right? Because the idea is that without the set intersection thing, right? From the answer, well, the answer is that, well, for each state, well, 3 has 2 to the n states, and we have an O of n loop for each state. So then this is going to be O of n times 2 to the n. This is without the group thing, right? And then the question is, well, is it that simple if now there's a group thing? I don't know how to prove this, honestly. Experimentally, I played around, and I found that the max is actually O of n, but honestly, I don't have a strict proof of that. Yeah. Well, okay. Actually, I think I get it. Actually, yeah. Because I see. I think the proof is a little bit tricky. I'm a little bit shaky about it. There is a bound though. The bound is that, of course, you can say, well, are there possibly 16 possible answers? Well, the answer is no, because it is still restricted by R, right? And R, because of the property of +1, +2, means that let's say your delta, let's say you have 8 numbers left, and your min number is 4, meaning 4 of them are 1s and 4 of them are 2. That means that in the worst case, you have 8 choose 4, which is not a big number. So you can kind of use that logic a little bit. Maybe someone will challenge me on this, so I don't know, but it does pass the worst case, a couple of worst cases. So yeah, honestly, I'm not quite sure. Hopefully it's not too bad. We'll see. Maybe this fails, but that's how I did. And then at the end, I take all the groups. I go, okay, and I just convert it to bitmask, like from bitmask to the result. This is the lookup key for the character, but yeah, and as we said, if the bit is a 0, it is a 2. If a bit is a 1, it is a 1, and that's it. Yeah, the complexity again is a little bit unclear, but it seems fast enough. So yeah, so that is this one. So there's another way to do this problem, it turns out, which we'll do it together, maybe. But the idea here then is what did I delete? The idea again is this feasibility thing, right? So as we said, each number or each part of the answer has to be 0 or 1 or 2, right? So then here we just brute force all of them. That's basically the idea of what we want to do. Is that okay? Well, you know, and we could do this with bitmask, but let's just do it recursively, right? So here maybe we have like a I don't know, current thing, right? So if length, maybe like a current index thing, I don't know, whatever, right? Again, if you want to see the live portion, you can skip ahead. This is going to be me live solving the other part or another attempt, and I'm going to go over, yeah, so current is equal to, yeah, whatever, none times n, right? And then here, maybe we have answer is equal to array, right? And then go current 0, right? And then now it's just for each index, is it 0 or 1? So if index is equal to n, then we do stuff. Otherwise, we just go current index +1, except for current of index could be 1. We do recursion, and then this could be a 2, also recursion, right? And that's it. I guess you can, I don't know, if you want to be clean. Right, and then now this is okay. So there's 2 to the 16 possibilities that we already tried. So then now we're just trying to figure out if it's possible, right? Well, what happens? Well, the thing is that at this case, maybe we'll just have a if good of current, but also if well, let's have a best answer first, right? So best answer is equal to, I don't know, 2 times n is n +1, so it's like an infinity, right? Because you can't get there. But if sum of current is less than best, or less than or equal to best, and good of 0 to current, then answer dot append, I don't know, convert current, right? It's fine, something like that, right? And we'll write the convert later, but that's basically the idea, right? Is that at the end, if this is a possible answer, then actually we need this to be if then if this is good, then actually it's not just enough to append it, it's actually it is the only answer, right? Because it is a new answer. Else if sum of current is equal to best, then if this is good, then we append, right? And this is just regular type breaking things. And then now the question is good, or how to implement good, right? So good current array, right? So this is, it turns out that if an item has two things, we don't have to care, right? Because as we said, we just put them one in the beginning, one at the end, and it has every possibility, right? That's it, every possibility, right? So they only care about the things with one thing. Well, what happens with things with one things, right? Well, the things with one things, it turns out, then now you just want to see if there's a cycle. Because if there's a cycle, then you cannot finish it. If there is no cycle, then you are very good, right? Because if there's a cycle, then that means that using one character is not enough, because with a cycle you need at least two characters of one thing. So that's basically the idea. So okay, so here maybe we just have like and I'm implementing this live even though it's afterwards, so forgive me if I'm a little bit wonky. You could watch this on a faster speed, but that's basically the idea, is that okay, now we brute force every numbers two instances and one instances, and we just go over all the numbers that we care about, right? So for I, X in current, enumerate current. Yeah, and maybe I have to kind of think about the list here differently, right? So then now we have an adjacency list. I don't know. Well, if X is equal to 1, this is the number that we care about, or the index that we care about. And then now we want to just say topological sort or breadth first search. It's not really topological sort, though topological sort gets you to the answer as well. But yeah, so then it's just making sure that all the requirements are met, meaning you can go from one to the rest, right? In some order. I guess it is topological sort actually. What am I talking about? Right, so here times I don't know, length of care, right? Yeah, and then now and then now for X for X in care, this is the whatever we care about. Then we look up, we just set up in degree is equal to, in theory, the length of the out degrees, right? Or in degrees, sorry. So the length of before of X, right? So here now we don't want a bit mask anymore. We just kind of want to append this thing as the before, right? It's just slightly easier to work with, right? Oh, here I think I have to write something, which is that only if so we can always do 1, right? Is what we said. So we actually want this to be I forgot about this. Current, what was it called? What is index? Index is the number corresponding to O. So O of index is not in F, then we try with the 1 case, right? Because if it's in F, then there's no point. We need 2 of them by definition. Okay, so here we have right? If in degrees of X is equal to 0, that's not quite right actually, because we have to remove all the numbers that we don't care about, right? So okay, so maybe we can, is this fast enough? N square? Maybe it is. I don't know, we'll see. Yeah, okay, fine. Then we don't. Yeah, okay, right, fine. We'll see. For Y in care, right? So yeah, if if x is before y, right, then y has an in degree, right? And that's it for the in degrees, right? We have to make this a set, just make this slightly easier. And then now it's just, I don't know. Is that how I want to write it? Because the I is k sub I. Okay, fine. Okay, fine, whatever. Okay, so then now if x is equal to 0, then we're good with that number. That means that k sub I is free, right? So then now, and we want to append it to the topological sort queue, right? And then while length is greater than 0, we can say, yeah, maybe we have a done a Boolean set thing, right? So then now, yeah, now is equal to q.pop left, right? And then now we look at its neighbors, which I guess we didn't set the graph. We set the before, but not the edges. Okay, fine. We just need to add it. I mean, maybe you could write it in that way. I don't know. Maybe this is also, maybe I could just write like for x in care, if now, or if x is in before now, or no, the other way around. If now is before, if this is true, then in degrees of x decrement by 1, if in degrees of x is equal to 0. Actually, I guess we don't need done then, right? In this case, we q append yeah, we q append x, right? And then now we just have to return whether sum of in degrees is equal to 0, because that's just what happens when you relax all the nodes. I think that's maybe right. I don't know. Does it apply to an int object? Do I have a typo somewhere? Probably. Isn't before a set? What am I looking at? 21. Add for a set. Huh? Wait, what? What does this mean? Am I confused? I mean, I'm definitely very confused right now, but oh, we didn't do convert. Okay, so I guess that was it. Why doesn't that? Oh, because it's not as, because what I needed was not that. I got confused. It should, if I write it this way, it should be this. That's why. Yeah, and of course we have to convert this back. It's fine. Silly things actually. Okay, and then we have to write the convert, which is in this part, to convert the answer, right? And actually convert we actually already wrote, but in the other kind, whatever. Okay, fine. Right, so then now it is O of x minus O of a, right? So that's an int. So then now, I don't know, O of I? No, wait a minute. So O of this, which would give us the character that corresponds to the index I, and then result of this is equal to I, right? Or X. Oops. And then we can return R, and R is just equal to none times 0 times 26. And yeah, I mean, this isn't right, so that's no Gucci. But in theory, we're close. So yeah, like I said, feel free to fast forward a little bit, but that's the second part of it, right? And we'll go over it really quickly as well afterwards. Don't worry. Maybe worry a little bit, but we do solve this, right? Like, what's going on here? So we do all these. 2 is a little bit weird. Well, it means something's very wrong because 1 2 and 2 1 should have meant that 2 2 doesn't get used at all. Okay, so why is that? Am I printing? The current is 1 1, so yeah. Care 0 1 index, and then in degrees 1 1, right? Okay, so that means that it's not possible. But you have one of them. Then now 0 0. But that already means that this is equal to 0, right? So is that not wrong? So current is going to be true. Huh, why is it returning false? What? Oh, well, this is false, but this should be true, right? Yeah, so that should be true. So then why? Oh, man. No, this is true, right? So we should be at least here once. So then why is that not a... Yeah, so why is that not... I don't know why we would convert that one, if that's the case. Oh, we don't update best because I am not a smart boy. Sum of current is equal to... very silly things today. Right. I'm going to do a non-local. Man, maybe I am rushing too much. Like, I don't know how I missed this. Okay, still wrong, but at least, you know, it does print stuff. Oh, I'm dumb. This has to be inside, Larry. Also non-local answer. Alright, so that looks good after a lot of silly mistakes. Sorry, it's very late and I'm tired and I need to get food. I'll make food rather. Ooh, wrong answer. That is weird because I thought that I thought this would fix that. O of index not in F. F0, right? So then Y. O of index is what do we put in F? We put in the lookup, which is the index. So this should be if index is not enough. I'm noob. And we could have tested, but I guess I did not. Yeah, there you go. I'm just, oh, well, in degrees of y, is that, well, where is this? Oh, k is the index, so, wow, a lot of silly mistake, right? So y is the index, but not the index of k. That's actually pretty bad. Whatever, we'll just... I am having a wrong answer moment though. Again, why would you append? Oh no, I'm just really wrong. Why would it not try 211? Well, this is no longer right, that's why. Still well. I'm making a lot of silly mistakes, my fault. But you can skip ahead a little bit. That'll be good for us. But what am I making mistakes on? Just in case, I guess. I don't think I needed it, but. Why would it? I mean, say I have only this. Does that work? Nope. Why would it not work? I mean. Oh, it doesn't sum the values? So 1, 1, no, it sums the values to 1. But that shouldn't be the case, right? If now is before x, then we execute x, right? I don't know, friends. I am struggling. And the idea is right. I'm just being sloppy, I think. But okay, so Q. I mean, we don't have a Q, so that means we're not appending here. I is in degrees of I. Oh, because now this cannot exist. I see. Because we don't. Yeah. Okay. Because there's no zero value. Very subtle, I suppose. 45. All right. Now we're just debugging a lot of things. I don't know what happened, but I. What is I? Oh, this is the index of the thing. So, so that is the original number, and then the care. This is actually the reverse number. So actually, we just care about I. Okay, there we go. Maybe a lot of silly mistakes I'm making. It's just I'm making so many references, right? So that's why it's kind of hard, because it's like, okay, this means something else. It's an indirect. I'm not like a pointer reference, but it's still like an implicit reference, right? 2.1 seconds. But yeah, let's go over this solution real quick. This thing doesn't change, right? I just have. In fact, I don't even use this, even though I thought I would. I guess I could have, but instead I'd use the for loop here. You could be a little bit more precise, but yeah, this is just the same as before. We already talked about it. I can go over there here. This is the 2 to the n thing, right? You could make it a 1, or if you could make it a 1, try making it a 1. Otherwise, make it a 2. And then here, this is just logic to get the answers, right? If it's tied, then n is good. And the reason why I wrote it in this order is because this is expensive one, right? So we want to only do stuff that is not expensive. If it's tied, then we append the answer. If it's better, then we go to the answer, right? We update it as the only answer. The conversion is straightforward. As we said, everything is either 1 or 2. So you just kind of convert it from bit mask, or actually in this case, it's not even a bit mask. I just kind of go 1 and 2, right? On the array. And here is, for all the things that we have only one element of, we want a topological sort on it. Even though it took me a lot of time, because I don't know, I just try to make it. I think you can probably just do it for other things, but But in any case, yeah. And then if you are able to topological sort all the items, meaning there is a way to get through all the items, then yeah, then you return true, and that sets up the logic here. So that's it. This is the complexity here. Well, the way I wrote it is a little bit sloppy because it's 2 to the sorry, this is n squared because of this and this. You can actually just write you can do better than this, but maybe not that much better because it's n squared, but it's actually on number of edges would be the lower bound anyway. So maybe that is a little bit tighter. But n in this case is 16. Just sorry, not the size of the input. N is the number of distinct characters. So n 16 squared is fine, right? And yeah, and that's topological sort in 16 elements. And this is the 2 to the n where n is 16, right? And that's it. Yeah, let me show you the top, the good function, the satisfactory function, and then the bottom. And that's all I have for this one. It's 2 to the n times n squared, or n squared times 2 to the n time, and space is much better, I suppose. It's like 26 times whatever the answer is, right? Output sensitive. So yeah, that's all I have. Thanks for watching, and yeah, you could watch me solve it live during the contest next. And if you must, or if you don't, not must, but you could watch all the way at the end when I was very close to getting it. I think for me it was very exciting, but you know, let me know what you think, because I got it with like a minute left. So anyway, that's it. Thanks for watching, and you can watch me solve it live during the contest next. 2 and 4. All right, YOLO. Okay, that wasn't so bad. No one's gotten Q4 yet though, so I have 10 minutes of penalty to catch up, which is not great. Alright, what is this? 256. What is going on? I mean, that already sounds like it's a really hard problem if this is the case. Let's see. 5 minutes, wow. I feel very fast, actually. But I also have 10 minutes of penalty. That's yikes. Alright. We have an hour, it's fine. Maybe. Shortest common supersequence of which they're not permitted. Frequency that would be what? I don't even know how to read this, honestly. Maybe that's why no one's gotten it. It's not great. Funny thing is that I did something similar for. The 256. Oh, they're only 2-letter words. Why is that not in the thing? Why are they allergic to putting the problems in the problem? 16 lowercase letters. There are actually a lot of constraints here, even though I don't know what that means yet. I don't even know how to think about this, honestly. Is there some brute force thing we can do with 16 letters? Is there a bit mask thing? No, I don't think so, because you still have to count matters, and you have 500 letters each at most, or something like that. Whatever. They all have to be unique. What does the unique thing get us? 256. That means that each character can be at most the first character in 16 strings, right? How do you even get the min? Alright, let's start with that. What is the min length? It's 2 characters, right? It feels weird. Oh, super. It's subsequence, not super well. Is it just 16 factorial? Is it just 16 factorial? No, not really. ABA and BAB, so that's actually kind of tricky to return both. But okay, so each character can only be the first character once. The 256 is not even possible, is it? No, I guess it's 16 square. So that's the worst case, is 16 square. What is the case in that one? Is it just a debugging sequence or something? Maybe I'll just write out the brute force. If they're two, let's just write. If they're two, if they're unrelated, then that is good. If they are, then you just kind of put them together, right? If they are related, that's how you, okay, let's say ABAC, what does that mean? You just ABC, and that's it, right? There's some like weird graph thing of like A has to be before B, but not all of them, just at the minimum number of them, right? So AB, BC, AC is just ABC as well. But then if ABB, no, that's fine. And then, but the tricky thing is that now, what if you have AB, BA is one, but you have like a weird psycho-y thing. Can anything force ABBA? I guess so. AB, BA, BB, right? So that would force that. So that requires a cycle from B to B. So we have edges and all these things, right? Still no one got it, and my 10-minute penalties really hurt. So the super sequence is just a common sequence, right? But how do you do that over all these other numbers? Or other strings, rather? Can it be greedy? Well, not greedy, but just like put things on, because this actually could also be this, right? So it doesn't. So then when do you have extra letters? What are the required letters, right? A, B, B, A, so those are required. How do you know that there are extras that are Okay, what is the worst case? Worst case is it just like ABC? Is that the worst case? I mean, well, with more letters. And the reverse of it? Because then now you have AA, AB, AC, AD, AE, ... And also GA, GB, GC, right? So this is the worst case. So 31 is the worst case, right? 32. And then it's just about what's in the middle. Maybe. And if you have letters by itself, they don't connect. Okay, so what happens when you connect? One person got it already, finally. What happens when you connect? Has it been 10 minutes? Yes, it's been 10 minutes finally. So maybe my ranking will stop going down. Okay. But it can go up, Larry. Okay. So the worst case is, okay, so let's say you have connected components. Then what happens? Okay, so everything that's not connected we can do, right? Okay, but then now what happens when you have connected things? So you have A, B. AAAC. I mean, AA almost doesn't matter, but it's hard to kind of be precise about it. What if you have like AA, AB, and BA, right? Then what happens? I guess it doesn't matter. It doesn't change. Well, in this case, then it would force this one, and this one is no longer true, right? How do you codify that? I think this is going to be the thing. So then, okay, so let's say just three letters, but yeah, 3 unique letters, right? And now what? It's just same as ABC and then AA, right? How do you force another letter? Or when do you force? Okay, so here it is just ABC, right? We share the same first letter and then ABC. Maybe we'll try brute force. No, I mean, no, there's no other first letters. Okay, let's try something else then. Right, let's say AA, BA, CA, right? First letters, we try A as the first letter, and we get, well, it's not possible. Not that it's possible, it's just impossible to get minimum B. What about B? BA? So okay, what is one possible answer? Right, something like this, which you take out the double A. Actually, you take out 2 double A's. So this is still the case, huh? Right? And you even do BCAA, but and you can also do CBAA. But it gives you the same answer, but that's fine. It's some ordering on 16 factorial, maybe. So how do you get extra letter? Only time you get an extra letter. Okay, so if there's a defined ordering, right, then it is just literally, well, that's just a topological sort. So what happens when you have a topological sort with a cycle? How do you handle topological sort of a cycle? Okay, so then now let's say we add, because AA we can trivially remove, it feels like. We just add 1 at the end, but ABA, so there's a cycle here, okay, fine, but let's say there's AC, right? What happens? Well, we have BCAA as one possible before, and then now we have to create a C. So, and that's it, right? Is there any other possibilities? So what makes this case so weird is that we have AB and then BA. But then now if B goes first, we have BA and then B, right? In this case, does it matter which goes first? We have C, B, AA. This is still C. So the answer is always going to, okay. So the answer is always some variation of A, B, C, D, you have dot 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 all the way back, and then we just remove. Can we think about it backwards in removal? How do we think about it in removal terms? Okay, so for example here, and we have different cases of things in the middle, which is what brings on the thing, right? Actually, it's just, so the only thing that matters is the thing in the middle. Actually, not the beginning, because everything else is mirrored, and that's okay. We have to think about it a little bit better, actually, than that, Larry. But because it just means that everything gets every paired, but we don't need all of these pairs, right? So we can sort the left too. So if we're able to sort the left, then we remove something from the right. For example, if so something has to be on both sides only if there's like a weird cycle-y thing, right? So we brute force on the middle character, maybe. And then it is the is it the longest path that we want, or the thing that satisfied the most things? 2 to the 16 on the left, so it's, I mean, that's enough for DP, right? Okay, okay. 4 people got it. I don't know if that's the right approach, but maybe that's a fun idea. Because the cost is that we have to do one more. Okay, and that only gets us the min, just to be clear, Larry. How do we... So the answer is always 1 or 2 or 0. So that's the thing, right? So that means 3 to the 16 is going to be too slow, obviously. But, well, it's not going to be 1 or... Oh. It's going to be 1 or 2. Always 2 if it's, you know... Yeah, it's going to be 1 or 2. So you can brute force whether that is enough. How would you... Okay, let's say you have 1 or 2. How would you brute force a Larry? How would you check whether it is satisfactory, right? Well, okay, think. All right, slow down. Yeah, for 15 minutes. Okay, so then now we want to say things are either on the left. Do we want to do an ordering or a left-right thing? What does it mean to have one thing? Okay, so if AA or whatever, then they don't have choice. It always has to be 2. So these are all 2s. Okay. So then now, all the other ones are either 1s or 2s, right? So that means C is either 1 or 2. In this case, it's 1. In this case, they're both 1. Max is 1. So then now which is not good enough. Right, how do we do the satisfactory thing? Okay, so 1, 1 is not good enough. Why not? How can we show that it is not? Without let's say we have this one, right? So you know that AA has to have 2, okay? Now we try brute force whether there's 1 or 2 on these things. It turns out that there's a cycle here, so do we just brute force the middle? If A is in the middle, now we will not do anything with A should be in the beginning and the end. Is that easier to handle? Yeah, A should be actually always be at the beginning and the end, because then now satisfy everything else, no matter what, right? Okay, so then now you have a B or a C. Well, 2 C's, but it's okay. So we brute force the other letters in the middle. So let's say B is in the middle, right? Then now we go, okay, can B satisfy A, so we don't care about that, and then C is before and after. Did I mess up? Was that? Is this not min? This is not min. I lied. That's where I got wrong. ACBA satisfied all of them. I lied. So if there's 2 of them, then yeah. But what if there's a B? Okay, if there's a BC or CB, then it doesn't really matter, right? So then, okay, so we brute force B in the middle. Then everything else we either so if something appears once, we just brute force in the middle. Okay. So let's say we have ABBA, which is the first part. So then now we brute force A in the middle, and then we just, well, we see B before and B after, so we just add both. But if this is the logic, then it would not have, you know, this constraint doesn't make sense, right? And then you try B in the middle, and AA. I guess it's the ordering, right? Because if we put both, then what? Okay, fine. But if let's say we only have AB, so then now we have AB, B, C, then now we brute force B in the middle, A has to be, okay, fine. Which we say A and then B, right? And then now we have to do BC again, which it still should be on the right, obviously, but how do you formalize that? Okay, so if it's 2, then you actually just put it on this edge and it really doesn't matter, ironically. Then just fix that 2, right? So the only time that matters is if there's a cycle, right? So that means, let's say CA, right? Then now what? Well, A, we have to put a C in the beginning, or a B in the beginning, right? Or an A in the beginning, something like that. So there's only a how do you formalize that extra letter? And there are more than one crazy cycles. If you have 3 elements, there's a 3 cycle, but if you have 4 elements, then what? Right? So the worst case. Maybe we got it. Good amount of people are getting it. I have couple of ideas. Okay, so is 1 enough? If there's 1, how can we test it? That's it. We only forced to only have 1 B. And how do we test this idea that there's a number that there's a thing that satisfied everything, right? So if there's only 1 B, has to be in the middle, right? Does every component mean that there's a what does a connected component mean? Does it mean everything in that component has to have 2 except for 1? I don't know. I don't think so, but okay. Focus. Go back to the min, right? Two to the 16 of the min. Let's just say we do an n times 2 to the n min. So then now we just do 1 at a time. What does that mean? That means that we have put in a 2. If the number is a 2, that means everything with that letter is satisfied, right? And then now, what does that mean when every number with a... What happens if you have a 1? 1 means all the prefixes are satisfied, but not all the suffix. Okay, oh, I see, huh. Maybe, I don't know. Okay. Oh, maybe the other way around, actually. And then we want to say there's an edge from here to here, right? So something like that, maybe. We're fine. Let's use it as set. Okay, and then now say used as a bit mask. Is that good enough? Actually, this should be a bit mask, right? And then I don't know if that's right. I think that's just counter, but anyway, whatever. So then okay, fine. And then now okay, it runs. And now we want to say we want to use 1 or 2 letters, right? So okay, so oh, if it's itself, then it has to be a 2. Cannot type. Okay, so then now if e sub I and used no, wait, no, it is whether there exists an edge from the remaining ones that needs to do it, right? So okay, so it's not used, and actually then now in that lookup case it is actually the other way around. So that means that z, let's call it before. Okay, so then now if before sub I is afterwards, right? So actually we want to count down. So if these are the 3 things, right? That means that the things haven't been done yet. So if they're numbered before, then you cannot do it, or at least it'll take 2, right? So this is greater than 0, then yeah. Oh. Is it min? Yeah, min, right? Not max. Yeah, we also have to check that now we remove the I, and then this now has 2. Nope. I guess I did need to use it after. I had to do something about this one actually. 3, 2 is wrong because of the AA. 3 is also just wrong because of 3 of these things. Okay. So so it's force, right? So yeah, so okay, so that means that here, yeah, okay, so if this is 0 to 0, then we write some equivalent, but it has to be this and I not in F. 336, is that right? 336. Okay, so I think this is right-ish, right? Half an hour to go. Now we have to actually return the thing, which means for which states do we go, right? Do we do path construction? Yeah. How do we do it, actually? Because otherwise this is done, but I mean there's only a because I didn't write it that way. That's annoying. Actually, I thought the path reconstruction would be easy, but it's not quite that, right? It's not. Maybe it is. Maybe I'm just complicating it. Oh, this is not an else either. No, maybe it is. Because you would never do it anyway. But no, it is because we have to do tiebreakers for the other thing. I think. How do I do it? Without getting all the possibilities. I actually have no idea. This is pretty bad. I feel like I was close. Well, I am close, but maybe not. without, you know, because the path, they give me a lot of paths. Okay, let's say we know the min, right? So this is the min. Then now what? On 16 choose 8. Choose 8 is not that bad, so that means that we want to how do I do it? I get the min, but how do you do it in a way such that doesn't matter? And also, I don't know, huh? That's bad. How do you do it without 16 squared? 2 to the 32 is definitely too slow. So then how do you do it? How do you do it? Huh, I didn't think this part would be that hard. Or like, you know, I mean, I thought it would be hard, but just not like after you get the answer. Two to the 16, what's that math? 2 to the 16 times 16 times 12,000, what is that? No, that's too much. 12 billion. I can't do that. So you only save how do you reconcile the ordering? Without ordering the count. Alright, let's say we have a count number of ways, right? Let's just do this. No, because the 16 factorial, mine, like over 16 is probably like the worst case, right? So I don't. How would you do it without needing to know? Maybe I just don't know. I thought I did, but maybe I don't. Huh. I don't know that I could prove that bound either. Okay, this should be just n times 2 minus this, right? N minus this is the number of, no, this is the number of unique things that have 1. So then it's just, do them in order. I don't know how to do them in order. What does it mean? What does it mean? Okay. So we return 1, so 1 freedom. I thought I was close, but jeez. The output, I didn't expect that, honestly. That this would be the hard part. I mean, well, maybe I thought about it, but okay, for each component. It's not true that all of them can be whatever, right? So you have AA, BA, CA, AC. It turns out to be C. And for second C is just this, right? Double checking. Four, right? Oh. this for? What is the answer? That is the answer. Right, and then you can also have CAC and B. So that's actually two answers, but how do you determine them? And it's not just anything in the component, because B doesn't care. So for a K2, I don't know. I thought I was close. At least on the DP I would be close, but that's not enough, is it? And I've only 15 minutes. I don't know that I could do it in 15 minutes. I don't even have any idea now. I thought I would by the time I'm here, but nothing that is complexity-wise good. Three to the 16 was 3 to the 16. 3 to the 16 is too big, so it's not that. It's not ternary thing. So close. Oh, I don't know if it's so close, but it's feel like I have it. I have it. Come on. How do you even go? You have to try, Larry. You have to try. I don't know. Okay, so then now if this gives me ones and twos of every plane, right? That means that if this is the case, then so now it's 6. So each of these should only have 16. But then it's no. But then it. Oh, this is a number, isn't it? But it doesn't matter because it should be a bit mask actually, but then now this is how you get like you have to do. I don't know. That's a set. What am I doing? It's the same, but I never said. For each element. If it's the same, then you just want to add it. Okay, fine, right? Non-editable int object. Oh, because I do go and not go to. What does that mean? Oh, this is the +1. That's not great. Why? Each previous number and also, okay. That's not right. We want to only add numbers that could be a 1, not a 2. Right? Only 8 minutes left. I think I'm... How do I do it? How do I... How am I... That means that the previous could have an I. But that's not the I, right? We only care that the previous... Oh, because they're now. Okay, so it's. I don't know if this is good enough, honestly, but. And it's a 2, right? 26. What is also by? AB, right? So yeah. Oh, I'm dumb. Yeah. Well, maybe just may time out, but at least if I get wrong answer, I'll be a little bit sadder. If it times out, I'm okay, because it's right, but I know that it's a little bit slow, probably, because it's doing a lot of work. Oh, wrong answer. Okay, that's a little bit sad, actually. Actually, why do I have that? That's weird. I'm gonna hack it. I mean, then I don't need this, but I'm so close. I have 3 minutes. Why? Two is right, so then why is it giving me a 3? Yeah, whatever. Oh, no. I don't know, this is just a hack. I think it still times out, but I don't know why, and I have no time to debug it. So it's probably going to be wrong just because this is such a hack. That means that something like really is wrong, honestly. But I expected to time out more than the wrong answer. Oh, but I don't know why did I think I returned something funky, honestly. I mean, I'm happy. Don't get me wrong. But I should not need this. It means that something. This is smell, right? And maybe it gets changed afterwards. But and there's only a minute, so I cannot realistically have time to fix it. I don't know if you could see the. I guess my face is blocking it, but there's 30 seconds to go. So, but I don't know. I mean, honestly I don't think this will hold 9 seconds. So probably times out. But even beyond that, I think there's a wrong answer somewhere. But I don't know. Yeah, now the contest just ended, but so what am I doing now? So the contest just ended. I was talking to chat, but my Discord. But I want to upsolve this a little bit. I mean, I guess this is right, but I don't know why this is needed, right? Because that should not return. So that is actually very weird. But the good thing is that this is yeah, see, even here we have the wrong answer for some reason. So that means that there is a weirdness that I'm having. So it should not. Oh, is it this part? Oh, I think now I don't need this part because I did the 0 thing. Okay. Because I missed the 0 thing, so that's why. Okay, I see. But let's see how much. I mean, I wish I did this during the contest because I'm only 2 minutes too slow, and you could see the running time. I did fix it, but yeah. But yeah, I mean, I imagine the worst case is already in there because the worst case is n is equal to 256, so I don't think it'll be changed. I'm a little bit. I don't know why I wrote it that way though. I mean, I was trying to get around this hack, and that's why. And then I mean, I know how it happened. And if I had an extra minute, then I would have kind of fixed it. But it's still just really. Sorry, friends. I'm just kind of after the contest, and that was honestly my heart rate was high. I was pumping because I was like, Like I felt close, but and I knew honestly I didn't know that I could have done this, but I just couldn't prove that it is fast enough. That was kind of my thing. Yeah, I don't know. But yeah, I mean, this is a way. I don't. If I didn't have to do this, I was done half an hour earlier, right? But yeah, I don't know. The cleaner version is better, but I'm trying to think about the bounds. I mean, I guess there is some like for science. I don't know, like what is the maximum here, right? So maybe we can just print BG real quick, or length of BG rather, and then we can kind of see. So I don't know. I think that my problem is that okay, so all of them only has 1 or 2 numbers, so maybe that's why. Maybe even like how. I don't know, like something really funky. What would that do? I guess it is just right. That's all of the things only have 1 or 2 elements, but I can't really prove that, right? Like what? I mean, I guess the worst case is just 2 to the 16, right? So it's just all unique letters. No, but then because everything is just 1 element, right? So then whatever you do, you would just do that. I don't know why this wouldn't be I don't know why this wouldn't be oh, because if I have double, I have an f function, so then this is all zeros, and this just adds the zeros because it doesn't add itself. Wow. Because the default it's 2. Wow, that is a really hard thing to prove. That is crazy. What is a case that I can even construct where I guess that's the reasoning, right? But I don't know the proof for it, honestly. I think that's the crazy part for me, I suppose. Like everything has a unique answer. I think that's the hard part for me. I mean, except for, you know, some of them has 2, but is that what just an n square thing? Maybe that's the thing that I was just too lazy to type up. Right, so here maybe, okay, whatever, just have 1 case, and then your input would be whatever, what does he go to do, right? For I in range of 16, for j in range of 16, right? We put it in, right? That's a j, right? What would that look like? Is that should be the max case, and the max case has unique, so I don't know. All the numbers have to have 2. Oh, well, I mean, of course, this is not the actual expected answer. I was like, did I do something wrong? But Yeah, it's not the actual expected answer because because we have this thing, right? Okay, so actually that makes sense actually, and it took yeah, sorry, too much printing. It took 0.2 seconds to run. So then now let's say I do a quick thingy, right? And then now, so okay, so this one has a lot of, okay, so that's a lot of answers, right? So here we have a lot of buckets, but they don't go beyond that, right? That is crazy. And we can maybe even put a bucket to kind of experiment with it. I mean, I guess that's what saved me, but what? Oh no, not. I mean, that's fine, but that also means So a lot of things just have 8 things, and so, a couple of things have 16, but 15. So I guess that's why. What is the sum of all this array, right? I think that's the other. Okay, 4K in C, right? So then here, whatever. Oh, that's terrible. I'm running out of letters. K times K, right? So what's that? So that's the sum of all the bitwise numbers that is stored in the array. I can't prove this. I mean, maybe there's some like combinatorial thing, but I think that's the short proof that this works. And without my, so before I had this really weird thing where I added this thing because I don't know. These are just kind of honestly the reason why I have them is because they're common E patterns that you would want to do. Even though, you know, but then here you have to keep in the if statement. Oops. But that doesn't matter. They only change the return statement. So here it's 524,000. If we remove this, we have the same amount. So I guess it doesn't change anything, huh? Like it's a little bit slower maybe, but yeah, okay, I don't know. I mean, I don't know how to prove that bound though. I mean, maybe someone you know, smarter than I am, and there are a lot of people smarter than I am, can kind of explain that part to me, I suppose. But so this is the thing where we needed this, and we have this thing. Oh no, I took it out. Whoops. So this is the good version, say. I mean, I still have this if statement, but it shouldn't matter. So this is the good version, and that took, yeah. Yeah, I don't know why I had this. I mean, I guess I do know why, but because this is a common pattern E thing that happens in a lot of problems. So I was just like innately like, because I was getting the wrong answer and I was doing that as a hack, right? And this definitely takes a lot longer. And the reason why it takes longer is because it still only gives you like a few more unique things. So I don't know. But this is actually wrong. It's just that it's not as brute force as it needs to be, but then here saves me. And I'm actually surprised that that worked, honestly. Because I didn't have, the reason is, and also honestly, if I didn't, if I had more time, I would have took more time to fix it correctly. But here I had 3 minutes left or something, right? 3-4 minutes. So I took 2 minutes to kind of just like put in the if statements, see if it works, and then fix it. And then I ran out of time, and then this was the thing. So I don't know. All right. You know, I mean, we'll see how it goes. It's a little bit off. We'll see if anyone challenges it. Please don't. I don't think you can anyway. Or I mean, Leetcode can add constant things to make it time out, but like they could add more test cases to make it time out. But that's just, I don't know. That's not the same as kind of having one test case cannot time me out, but you know, they could add a bunch of them, I suppose. But I definitely did a lot of lazy. That was just very incorrect, actually. But I haven't filtered out. That fixes it somehow. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye bye.